Welcome to Web Performance in 2023. I'm super excited. It's my third time here in Wix Engineering conference on the stage. And I'm actually very happy. I'm getting better and better slots. Before, I used to be after lunch, now I'm before lunch, so I'm making progress. It feels like I'm making progress in my career every year. So web performance and web development in general made significant improvements recently and especially last year. And you probably heard a lot of new terminologies, buzzwords like selective hydration, several components, islands. And so today I want to explain what those buzzwords mean, make some sense out of everything that's going on recently in web development and web performance. So hopefully by the end of this talk, it will be also more clear for you. What's the new standards? The standards definitely got higher and higher, especially recently. I really want it to be more clear for you what's the way to build a high-performance web application today. So hopefully you will know more about the features and the frameworks that you can use when you start a new web application, but also when you try to improve your current web applications. So for those of you who don't know me, my name is Gil. I'm a software engineer in Wix. I joined This Is Me in Costa Rica a few years ago on a mountain somewhere. And they're probably thinking about performance or not. So I joined Wix around 6 years ago. And in Wix, I'm a part of the viewer group. In the viewer group, we work on the application that renders Wix website. So whenever a user goes to a Wix website, our application runs and renders the website. And we've been working on performance for probably since the group started way back, even before I joined. And performance was always our main focus. And for me personally, I was a part of the performance team in the last few years. And especially I myself tried and did a lot of research on how to improve the performance of our web application. And especially this year, I made a long research about the new frameworks and new features that can help us in our application. And so today I want to share with you everything I learned recently, also about the research and about the findings. And yeah, let's get started. So we're going to start with a little bit of history. I want to do a short recap about the history of web development for all of us to be on the same page before we talk about what's new. Then we're going to talk about some performance issues before we dive into the features and the frameworks. I want to talk about the performance issues in general, like in high level, so you can really understand why we use those new features, why those features were even developed in the first place. It's really important for me that you will understand why we use those new features. And then we're going to talk about the high-level solutions. Then we're going to deep dive into the frameworks. I'm going to present a few of them, the big ones. And then we're going to dive into the demo to see actually how they work, how you use them, all the technical details will be in the demo. So, a quick overview over web development over the years. It probably don't, of course, I probably missed a few things, but overall we started with, it even started before that with just servers. But the most, I guess the most popular framework back then was PHP that served HTML. Of course, I never used it. It would be cool to use it in my resume. I think, is it gone? Is it back? Cool. So we started with PHP that rendering HTML, and then jQuery and JavaScript came to make the site interactive. A little bit after that, client-side rendering started. Libraries like React and Angular came to and moved all the code from the server to the client side. So all the code that used to be on the server side moved to the client side. It would, of course, it was easier for web developers to develop their applications. It was possible to still implement the logic in the server, but of course it was just easier in the client side, so we moved everything to the client side. Then a few years after, we moved back to the server side because client-side rendering was too slow to display pages, so we moved back to the server side to do the same rendering with those frameworks. Actually gave us the ability to run code in the server side. So then we run the code also in the server, also in the client. Then we came new stuff like static site generations that you can create your HTML in a publish time when you build the site. When you build the site, you can create the HTML, and then it would be much faster to send it to the client, and also code splitting to be able to separate code and to remove the unused code in the client side. So a short overview of what until today, and actually I wanted to show you that even though everything there were a lot of things happened in the history, we still end up with a lot of issues. Not a lot of issues, but very still big issues that make websites still and web applications still slow today. And we're going to talk about those issues. But before that, I want to show you a little bit about the trends recently. This is NPM trends. It's from the NPM, the registry that you install all the libraries that we use. So you can see React on the blue line. You can see, of course, getting a lot more and more popular over the years, and still is the most popular framework. A little bit under it, it's Next.js. I'm sure all of you know it. It's a framework built on top of React, and it's getting a lot of popularity, especially in the last, I guess, 2-3 years. A little bit under it, it's Angular. That's kind of steady, but not really going more and more popular as, of course, web development becomes more and more popular, but Angular kind of stayed the same. And the last lines, I'm going to zoom into those, the smaller lines, are new frameworks like the orange one is Remix. Who heard about Remix? Okay, a lot of people, good. Astro, nice, a little bit less. And Quik, which became very popular also recently. But you can see the trends, and we're going to talk about all of them today. So before we dive into those frameworks, I want to talk about web performance problems in high level. Again, explain why we have those problems so we can understand why we use those features. So the first problem is slow page load. Even if we have server-side rendering, still pages are loading slowly. It's especially for large pages with dynamic data because you have to fetch the data. There's sometimes a lot of data to fetch. You have to render it in the server. You have to fetch it from in the server side. And with pages with a lot of components, you need to render all the components, create the HTML, and then you need to send the HTML to the browser, and then the browser needs to display it. So all of that together on big sites with a lot of data and components still takes too long to display, and still users are still waiting for sites to load. I'm sure you felt it, and we feel it a lot. And another thing that I'm sure you felt is it's pages that takes time to be interactive. So it means that we need to make the site interactive. We need to, even if the site is visible, we need to run JavaScript. We need to download JavaScript and hydrate the components to make them so the user can use them. And again, we need to download the JavaScript. We need to run the hydration process. By the way, for those of you who don't know, the hydration process is rendering the component in the client side after server-side rendering, so they're visible, but you need to make them interactive, which means you create the state, and you also connect the event handlers. So we have a lot of JavaScript, we have a lot of components, and we need to do it in one big step, which still takes time. So let's talk about now the high-level solutions of those problems. Again, still keeping it high level without going into the details. So the first one, how do we solve the slow page loads, right? We want to display pages. They might be big pages with a lot of components. But what we can do is we can decide which components we want to display before others. Maybe we don't need to display the page, everything all at once. What we can do is we can use, and it's a capability that we have in the web for a long time, but it's becoming more and more popular, especially in Node.js. You can stream HTML to the browser. So you can stream components that are ready, that they are fast and small, and before you can stream it before other components that are actually slower and require more data. So if you do that, yeah, the page itself altogether will take the same time, but the user can see stuff on the screen, they can see something is happening, maybe they can see static content before other content is displaying, so it could be overall better user experience. And the second problem, or the second solution to the second problem of how to make the page more interactive faster, is we can selectively hydrate components. We talked about the hydration process, which takes a long time, but we don't have to hydrate all the components at once. We can decide which components are more important than other components, so we can hydrate them before others. We can do priorities. We can maybe hydrate only components that are visible to the user, and components under the screen will take more time and we'll hydrate later. And we can also not hydrate at all if some components do not need hydration because they're just text or images. So this is high-level solutions, and but now we're going to go over the new frameworks that actually solves those problems with the solutions that we saw. I'm going to go over the highlights of the frameworks, and all the technical details I'm going to leave to the demo. So I'm just going to go over the highlights, and don't worry, we'll get technical in the demo. So let's start with React 18. I'm sure everybody know React, and most of you I know using it. I'm using it. We're using it in Wix. And but React 18, actually, the new version of React 18 includes a lot of new and super cool features that help us solve those problems. We're going to go over them. So the first one is not a feature that we can use as users of React, but it's kind of like, implementation details, like a behind-the-scene implementation of React, but it is important to understand. It's a big change, so it's important to understand how it works. So concurrent rendering means that instead of doing the rendering in one big, large, long process, it's split into multiple tasks. And by splitting, now React can handle events, especially user events, during the rendering phases of components that were rendered before that. So now React can also prepare new screens. It's not running in parallel. It's still running synchronously in the browser, but it is helping us in better user experience, because now React can start rendering, can pause it to handle events, and then continue later to other components. And like we said, actually the concurrent rendering is used in those other features that we're going to talk about. So the first one is selective hydration. This is the feature that we can use, and it means that we can hydrate specific components whenever we decide. So, for example, if we have components that takes more time than others, we can make the fast components hydrate before the slower ones, which just gives better user experience. Each component can hydrate at its own time. We have the control to decide when to hydrate the component. We can prioritize components, the hydration of components, and just improve how fast it takes for the page to be interactive. The second feature of React 18 is server-side streaming. So we talked about how streaming components from server to client can improve the user experience. React 18 have the new render to pipeable stream API. We're going to see it in the demo. And we can use it to stream components to the browser. Slower, we can stream fast components before, slower components later, to improve, the user experience and how fast it seems like the page is loading just faster. And the third one, the last one and the most popular one is server components, which we can render specific components only on the server without even downloading them or hydrating them in the client side, so we can save a lot of code in the client side. It's currently only in Next.js. Actually, I'm talking about React 18, but the biggest framework that uses React 18 is Next.js, and we're going to see how I, as a user, can decide if I want to use those features only in React, but the user experience for developer, the developer experience, is actually better in Next.js, and we can see the differences later. So the next framework that I want to talk about, we talked about it earlier, getting a lot popular recently, is Quik. The main promise is in Quik is that it's zero JavaScript by default, meaning that there's no JavaScript by default when you develop your components. So it's keeping hydration completely. So how do they make the site interactive? They only execute and download JavaScript only for the components that the user actually is doing the interaction with. So it means that the site becomes interactive very fast because you need way less JavaScript to make the components interactive because you're only downloading what you need. And they're using it to do it, to implement it, they're using something they call resumability, which means they stream the data of the components from the server to the client. How it works is that when you fetch data in the server side, they save it and they stream it with the HTML to the browser, and then this is how actually the components are getting interactive so fast, because their JavaScript is not there, so they do need to download it, but the data of the components is there from the HTML. So kind of like overview of how it works in Quik. First of all, the server-side rendering renders the entire page. I could not find a way to stream components in Quik yet. I'm sure they are working on it and will probably release it as a different feature, but for now you have to render the entire site in Quik, the entire page. So the HTML is sent to the server along with the state of the application because, like I said, you don't want to fetch the data again in the client. So, and then no JavaScript is sent to the client. You don't need JavaScript to display pages. You just need HTML. And then when the user interacts with the page, then the component is downloaded and hydrated with the state of the component. This is how Quik is actually making the sites interactive very, very fast. Cool, so the next one is Remix. Like we saw, getting very, very popular, and I saw a lot of people compare Remix to Next. I don't know if it's as good, but it's definitely if people are talking about it, it's definitely in a very high level right now and getting very mature. A little bit about Remix. It's built on top of React, and it provides a lot of built-in features like routers, state management, custom hooks, and built-in components, which makes it very easy for developers to start a Remix project. You don't have to implement a lot of code that is already implemented by Remix, of course, when using React. It's server-side rendering by default, and it's combined with optional streaming for fast initial load time. So we'll see how you can use Remix to also stream components to the client side, and also prefetch data. Again, without any code changes, you can prefetch your data. This is something that Remix is doing under the hood for you. Prefetch all your data, similar to what Quik is doing, and prefetch the scripts and the data out of the box to eliminate the need for the component to fetch the data again. This is all done by Remix by default, and they have a built-in stack, including databases, edge computing, which actually makes the site even more faster, other features that makes it very, very easy for web developers to create full stack applications in Remix. And the last one I want to talk about is Astro, which is also getting very popular recently. The big advantage in Astro over the other frameworks is that it's UI agnostic. It supports React, Svelte, Vue, and other UI frameworks. So if you're migrating from one to another, or you want to use a couple of those together, you can do it with Astro. The way that it works is that they use something they call component islands, which means that they wrap each component in its own, they call it island, it's its own wrapper that you can actually download and hydrate. It's actually everything is in Astro happening outside of the by Astro. You don't have to do anything, and you can download it and getting hydrated by itself in parallel with other components, so making it very fast. It's zero JavaScript by default. All the logic that you write is run in the server side, and there's no client-side code at all until you except if you specify that you want to run specific components in the client side. And also it supports multi-page applications out of the box. Multi-page application means that when you do navigations, you don't run, you just do full refresh of the browser. And if the HTML is fast, like they implement in Astro, it has actually performance benefits because you don't have to download all the JavaScript to enable the navigations. So with a single page application, you actually you need to download all the JavaScript, but with MPA, you don't need JavaScript at all to do the navigation. You just navigate, you just refresh to the other page and get the HTML immediately, and it's very, very fast. So there are pros and cons of Astro. We're going to talk about it later, but the fact that you can use different component libraries makes it very, very popular. So now we went over the high-level features of the frameworks, but it was very important for me to show you the technical details, how they work. It's going to be a little bit technical, but I think it is important to see how things work in the code. So can we go over to the demo? We'll see my screen in just a second. Yeah. Cool, awesome. So we're going to go over React, Next, Remix, and Quik, and we're going to see how we implement the features that we talked about. So we're going to start with React 18. Like I said before, it is optional. It is in most cases, especially with new applications, most users are going to use Next.js. But it was important for me to show you how those features are implemented under the hood in Next.js and also in Remix. So this code that we're going to see right now is actually the implementation details of how Next and Remix work. But of course, as React users, you can use them. So I have here a simple React application, and I'm rendering 3 components to display, to kind of demonstrate how you can also stream components to the client side, but also how you can hydrate each one independently whenever you decide. And I have here, and I pass different times, so you can see later how I'm using these different times to hydrate and stream the components in different times. So by the way, it looks like this. Just before we go over the code, I want to show you how it works. You can see each component will be streamed in different times and also will be hydrated in different times. So this is how it looks like. You can see there is a part in between loading and hydrated, which is only server. The component was sent from the server and then get hydrated. And I want to show you actually how it looks in the HTML. You can see that the component has it's sent with the loading state to the HTML, but React is also sending some hint for itself that whenever the component is ready, this is where it needs to be replaced. And actually, way after, they're sending the JavaScript. This is actually JavaScript that replace the component, the loading state, with the HTML of the component after it was rendered. So this is kind of like how it works. First of all, the browser gets the HTML of the loading state, and then it gets the HTML it gets a JavaScript that replaces the HTML. So let's see how it works in the code. So I have here those three components. Let's dive into Suspense wrapper, which is the code that actually makes all of it happen. So I have here Suspense, which of course I need to use Suspense. Suspense used to be available before, but now it supports server-side rendering and streaming and everything we talked about. I want to show you the Suspense inner, which actually all the magic is here. I do create a promise here that I'm using it to resolve the component. Of course, in real applications, it would be fetched to the server or something like that. So this create promise is basically just creating the promise. I'm putting a little bit more time in the client side, and then I'm creating this weird function that I'm going to show you. Again, like I said before, it's actually not in the documentation of React, but React is suggesting people to use, developers to use Next or Remix, like the frameworks, to use those features, but I still wanted to show you how it works under the hood. So inside the Suspense inner, what I actually do is I call a function here. What I actually wanted to do, if the API was maybe better, is return a promise here, is return the promise of each component. But React probably didn't want to change the internal implementation, so they decided to use a different approach. So I call a function here, and this read function, it's implemented here. What it does is I have the wrap promise function. It takes the promise that I created earlier, and then it returns, the way that it returns the promise, you cannot return it, but you can throw it up to the parent component. So if you remember, the parent component is the Suspense component, and it catches the promise, and then it can listen to events on the promise and re-render it when it's resolved. So this is how kind of like the Suspense inner send the promise to the Suspense. Very strange, but this is how they implemented it. So here, back to the read function, if the promise is pending, I throw the promise. The promise is this, and after it's resolved, I change the status, and then the Suspense re-renders my component, and I return the status. Now here I don't do anything with the return value, but it's possible to, if I'm fetching data, now I can use it here. So this is like the internal implementation of how you can use it in React, but obviously this is how Next and Remix use it in their applications, and we will see the API. Before I jump into Next, I do want to show some other cool trick I can do here, but which it's going to be harder to do in other frameworks. So I'm going to now, instead of resolving the promise, I just save it and on the window object. And in the server, I return the empty promise, so it doesn't do anything. Let's see how it works now. So now everything is server rendered immediately, but I save the resolvers on the window, so now I can decide, I can call the function of the resolver of each component whenever I want to. So now I hydrated the third component, and now I hydrated the first one. And you can imagine how I can use it to maybe hydrate components whenever they enter the screen, for example, or whenever I think it's the best time. So this is the React 18. I do want to show you how Next uses those features, and this is probably a better way to use them. It's less customizable, but it's still very powerful. So this is Next.js, and this is a page component in Next.js. I have here a simple function that load post. The cool thing about Next is that you can write the async React component, which you cannot do with React itself. And you can see that this component is server rendered by default. So if you go into, if I show you this, you will see that I will not see the console log here. The console log that I post here, I only see it on the server side here. Because it's server component by default, because React, with Next, if I don't tell Next that it's a client component, it's server component by default. And it lets me do asynchronous operations inside the component, which is very cool. If I want to make it client-side component, if I'm using, for example, useState, I cannot use useState in a server component, but only now if I change it to client component, if it works. Without what? Oh, use client. Right. Thanks. Exactly. So now it's so now I can see it in the client side. Another thing that I want to show you quickly is how I implemented the feature that I just implemented with React, with the suspense and the inner suspense, everything we did there. I can do it also in Next, but I just need to use the new API from Suspense, which is called Dynamic. It's basically hiding all the implementation details we just saw from React in this Dynamic, and I have exactly the same behavior, just in Next.js, just using this Dynamic API. Everything is implemented inside this function. So you can do everything we did with React, you can do, of course, with Next. Cool, I want to show you, we're jumping from one thing to another. I do want to show you everything we talked about. I want to show you Remix, and I want to talk, it's similar in Next in that you write React Pages component, but they have some differences that I want to show you. This is a simple Remix page component. Basically, this is the component, and instead of writing the code inside the component, I have this loader function. So this loader function is cool because now Remix can control the data that is returned from this loader component. This is a lifecycle function to fetch data in Remix in the server. So let's see a little bit, and of course I can get this data inside the component, and we can see a little bit more complex example. Now I'm actually doing some asynchronous API inside the loader, and now I have two options. I have the option if I want to wait to tell Remix to fetch all the data before rendering anything in the client, or I can tell it to stream components to the client side. So if I call this await function, now Remix, this is the same example in Next, just in Remix. If I use the await function, you don't see the loader because Remix waits for all the data to resolve and then render the component in the client. But if I return, I can return a promise here, and then Remix, hopefully it will work. I do need to wrap my component this await component from Remix, and I do need to send the promise because I can have multiple promises if I have multiple data and multiple components that I want to stream in different times. I need to pass the promise here to the resolve of the await component of Remix, and then you will see that it streams the component. You can see the loading state, and then you can see Remix stream the component to the client side. So this is a little bit different than Next. I think the API, if you want to stream components, is actually easier in Remix, but it provides the same functionality. Remix do not use server components yet. There has been discussion about if they need server components, and they haven't implemented server components yet, but they do say, and a lot of people say that it's fast enough. Without it, let's go to Quik. I do want to show you something very cool about Quik, and we talked about it in the highlights. How you download the components only when you need them after the interaction in Quik, which is very cool. So I have here a simple counter component. I don't need it open, sorry. So this is a simple component, a counter component in Quik. Again, Quik is not React. Quik they are using JS6, but it's not React. You can see they're using different APIs to define state and to set the state. So this is Quik is doing it because they're doing a lot of code in build time. They do a lot of code in build time because they need to separate my event handlers from this code because they want to download it separately. Depends on the event handler. If I define an on-click here, they only want to download this code. Let's see it here. So this is the counter. And when I click plus, if I go to the network tab, Sorry, JavaScript. Only after I click the plus sign, you can see Quik downloading the component, and it's also downloading only the event handlers that I need to handle the event. So this is very cool. And another cool thing about Quik, you cannot see it in when I do the local host because they don't do the optimizations in local, but you can see it in this to-do list from production, that they don't download any JavaScript code to display this to-do list. You can see I'm in the JavaScript tab, no JavaScript at all, and only after I check the box, then you can see all the JavaScript downloaded and hydrate the component. So this is very cool from Quik. Yeah, this is it. This is it about the demo. It was a lot of things, but it was important for me to show you how things work actually in the code. Let's go back. Let's go back to the slides. I didn't show Astro because there's a lot of things in Astro happen inside out of the box. You don't really have a way to less control how to implement those streaming and the promises. Everything is inside the Astro. And all you do is actually write the component code, and they take care of everything in Astro. That's why I didn't put it in the demo. This is a big table that demonstrates everything we talked about. We talked about server-side rendering and selective hydration, which all the frameworks are doing. Server-side streaming, almost all the frameworks are doing instead of Quik. I couldn't find a way to do streaming in Quik. Maybe there is a way, I couldn't find it, and I'm sure they will implement a functionality for this. Hydrate on interaction, though, only happens in Quik, right? We saw only Quik can implement. Actually, maybe you can implement it by yourself in other frameworks, but it's definitely not a feature in other frameworks. Maybe you can hack it some way in React or in Next. Server-only components, we talked about, it's in almost every framework except of Remix. I know they are talking about implementing server components in Remix. We talked about UI frameworks, and also each one of them, most of them, have a meta framework where you can implement other features that helps just build web applications. Okay, so after talking about the new features, I want to talk a little bit about new problems that starts. They don't have to. I mean, it's not like those problems will always happen, but it's something that it's very important to pay attention to. When you're using the streaming, the server-side streaming, then it can lead to many loaders. We saw the loading state, and if you don't control it, if you don't organize it, it could be a mess from the user experience perspective. So it's definitely something to pay attention to when we're doing server-side streaming. It could also lead to layout shifts if you don't keep the height the same. So a lot of things can change and can hurt the user experience. So it's definitely something to think about when using these features. And also, when you're using selective hydration and you're splitting your components to multiple files, then you can have many network requests, which can also affect performance. So it's also something to keep in mind. Again, maybe there will be new features that solve those problems, but for now we have to solve them on our own. More cool stuff that I didn't have time to talk about. Of course, there are many other frameworks. Million.js, something very exciting. I only had time to read, but it sounds very cool. Angular, of course, have many new features. Gatsby for server-side generations. We didn't talk a lot about that, but Svelte also are doing a lot of stuff right now. They are very cool, and of course, if you want, you should definitely check out those as well. So to conclude everything we talked about, server-side streaming, selective hydration, server components are all very powerful tools to solve the big problems we have right now in web development, to improve page load and page interaction. And we talked about all the frameworks, React, Next, Quik, Astro, and Remix, to provide they all provide really powerful tools to implement the solutions. So what should we use? I'm sure you want me to tell you exactly what's the best, but of course, each one of them is best for different use case, and we should consider a lot of different parameters to decide which one is best for us. I think still, because of the community size, still Next.js is the most popular one, and they do implement a lot of very the best features that we have. But definitely there's a case for Astro, especially with sites that are, it doesn't have to be static, it could be dynamic, but all the dynamic data should be on the server side, and the client side, Astro is not the best if you have very complex state, because the sharing of the data between components, I think it's harder than if you use React and you know how the state flow works. So I think Astro have a lot of downsides in that area. But for sure, he has the use cases where it's better. Remix have use cases where it's better than Next. And again, like I said, you have to see you have to check which framework is best for your use case. Thank you very much. If you have any questions, I stay here, and you can come ask me. And one more thing, if you're interested in those subjects, we in the viewer, we work on that, of course, a lot, and we want to expand. So for sure, let us know if it's something that interests you and you want to take part in. Thank you.